Tell me, folks, how far is it from -1 to 6? How far is that? 7 units, right? So how far is it to go from 5 to 6? How far is that? 1 unit. So it's 7 over 1. There's your slope. Was it hard? And now I'm going to write all the little steps that you're used to writing to find slope that don't make sense to you, even though you perfectly did it without any of those little steps. Here's the steps to finding slope. This says find the distance between the y values. Oh, that's how far you moved in the y direction. This says how far did you move in the x direction. Okay. 6 minus -1. This says 6 minus 5. So 6 minus -1 is 7. 6 minus 5 is 1. Hey, look, it's the exact same thing you already got. So what this should tell you, and it's a good thing, is that you're actually not as bad at math as you thought you were. Doing the mathematics was easy. Writing it down, you got some struggles. Okay, so it's reading comprehension. Reading that, you're like, oh, that's what math is. No, us figuring out what the slope was in our heads without writing anything down, that was mathematics going on there. Okay, so same thing. Knocked it out cold. Well done. Okay, 89. Fair warning, this is the problem that takes a little bit of time because you're trying to find distance between two parallel lines. So it's a lot of work. This is a lot of work problem. I would say first thing we should do. Sorry, say again?
Draw a picture.
Yeah, let's do it. Okay. To find the distance between two parallel lines, what do we need? Yeah, we need 2 points, but they can't just be any 2 points, obviously, right? That's the thing. So the trouble is, and I see this way too often, folks, so be aware, people want to use these 2 points. They're like, well, those are 2 points on each of the lines, why can't we use those? Well, because when we want to find parallel distance, we're trying to find the shortest distance between these 2 lines. The shortest distance, that ain't the shortest distance. Shortest distance is a perpendicular distance. So if you find 2 points that are perpendicular between these 2 parallel lines, you're good to go. So you can't use both of them, but you can choose to use one of them. That's fine. In fact, I recommend it. So which point do you want to use? Top one, bottom one?
Bottom one.
Hearing more tops than bottoms. Okay. So bottoms up. Up we go. 0, 3, that's that point. So that means I now need a second point on the other line, and it has to be perpendicular to both of these lines. It has to form a line that's perpendicular. So we need a perpendicular line. Passes through that point, and then we can figure out where this other point hits. So we need an equation for this line. So y equals, therefore we need a slope that's perpendicular. Well, what's the slope here? We know the slope of these lines is 4. What's the perpendicular slope going to be?
Negative.
Very good. -1/4. And that makes sense because you see that line's going downhill, so it's definitely a negative. All right, so -1/4, and then, of course, x, plus, and now we need our y-intercept. Well, good news. The point you guys chose is a y-intercept already. So that's your number. 3 goes right there. Okay, we now have an equation for that perpendicular line. Excellent. We now need to see where that line crosses this second parallel line. So we're going to write that second parallel line right below it. -2. I'm going to put a bracket around these two. That means look at this as a system of equations. We now need to find out where they cross. The easiest way to do this is pull out your calculator, type them in, and find out where their intersection is. And that's fine if you do. I'm going to show you how to do this by hand in case you are called upon to do so. There's 2 methods to solve a system of equations. One is using elimination. It's where you add or subtract your 2 equations. The other is substitution, where you set them equal to each other. Which would you prefer? Doesn't matter to me. Substitution? Okay, so that's where we set these two things equal to each other. Okay, let's do that. So that would mean, oh, where's the negative? There we go. Negative 1/4 x plus 3 is equal to 4x minus 2. So far, so good. We just set them equal to each other. Okay, so this problem is going to involve fractions. Just get that out of the way now, okay? We'll deal with it. I'm going to add the 1/4 x to the other side. If I do so, I'm going to end up with, and can I add the 2 to the other side as well? Just do 2 steps at once. So we get 5 on the left. On the right, you're going to get 4 1/4. I don't want to write that as 4 1/4 though. It looks kind of weird to write that mixed number. I'm going to write that as an improper fraction. So 4 1/4 becomes 17/4. Is that right? Okay. So 17 over 4. That's 4 1/4. That's adding these two together. Okay. So 17/4 x. All right. So now we just need to solve for x. You can do that either by dividing both sides by 17/4. That's fine. To do this by hand, you need to multiply. The easiest way is to multiply by the reciprocal of 17/4 on both sides. Let's see what happens when we do that. Okay. On the right side, you're going to get 4 times 17 on the top, and on the bottom, you're also going to get 4 times 17. So that simplifies just to 1. That's the reason why we multiply by the reciprocal. It cancels out or simplifies our fraction down to 1. So on the left side, we're going to get 4 times 5. That's 20 over 17 equals x. So we have our x value. Great. A lot of work just to get the x value. Now we just substitute that back into either one of our equations here, and that'll tell us what our y value is. It doesn't matter which equation we use. This one looks a little more friendly though, so I'm going to go with it. So y is equal to 4 times 20 over 17 minus 2. Okay, so 20 times 4 is 80 over 17. People wonder if they should multiply top and bottom by 4. No. This is the same as 4 over 1. So tops multiply by tops, bottoms multiply by bottoms. Okay, so we got 80/17 here. I'm going to convert that 2 into a fraction. So this is going to be 34/17. That way I can combine them later. I actually want to make one number out of this. So this is the same as 2. Okay, 80 minus 34. I believe it's 46/17. Okay, whew. A lot of work. Sorry, say it again? Sure. I wanted to convert this 2 into a fraction, so I want to convert it into 17ths. So 2 means I'm going to have 2 groups of 17 over 17. So that'd be 34/17 that I have. All right. And from here, folks, it's the distance formula. So I will save you from having to watch me write it again. There you go. Straight up distance formula. How to get that number? I use a calculator. There's no way you're doing it by hand. Okay. When the numbers are clean and you get nice round numbers, whole numbers that are perfect squares, not a problem. Here, you're not going to get perfect squares. So we will save ourselves the time and just convert this immediately using a calculator. If you were called upon to do this by hand, like you were on the benchmark, then the numbers would be clean enough that you could take the square root and solve. Here it's just going to be messy. So write that down, and then your calculator is going to be your friend there, this particular problem. So before you turn the page, recap for me. We needed to find 2 points and then find the distance. That was our goal. We had to choose those points such that they formed a perpendicular line to our parallel lines that they lied on. That was the big thing we needed. So we plotted our lines, we chose our first point, we came up with an equation for this perpendicular line, and we found out where it crossed our second parallel line. And once we had our second point, we use the distance formula and we're off to the races. So it's 4 steps. Choose your first point, get the equation for the perpendicular line, find out where it crosses, get your second point, and then use distance formula. So it's 4 steps, basically. They're big steps, but it's just 4 of them. Turn the page. Okay, number 99. Here we're trying to find the geometric mean between each pair of numbers. To remind you, this was from chapter 8-1, so that would have been like the week before we left for a break, the week before that. To find the geometric mean of two numbers, say those numbers were a and b, you would write them as a is to x as x is to b. And then you cross multiply and take the square root, solve for x. So the a and b would be called the extremes of this proportion, and the x values would be called the means. Sound familiar? Remember this? Yeah. Okay. So we're going to do the same thing with these numbers they've given us. So we can say that square root of 225 is to x as x is to the square root of 361. And now we're going to cross multiply. So we get x squared equals, the square root of 225 actually is a perfect square. It becomes 15. And the square root of 361 also happens to be a perfect square. It's 19. However, if you didn't know that, you could multiply these two numbers. You can multiply square roots times square roots. They're like terms. And then you can take the square root of them. Your calculator would simplify it for you. So last step, we need to take the square root of both sides. So x is going to equal the square root of, and 15 times 19 is not a perfect square, obviously. 15 is 3 times 5, and 19 is a prime number, so we're going to just need to leave this as a square root. 15 times 19, it's like 15 times 20 is 300, so 19 would be 15 less than that, so it would be 285. Check me if you will. So, totally possible to do numbers like that in your head. You just need to know a couple tricks. Okay, so there's our answer, C. Well, we're taking the square root of 15 times 19. 15 times 19 becomes a 285, and we're taking the square root of it. This doesn't simplify. We know that because these are not perfect squares with each other. 15 is the same as 3 times 5, and 19 is a prime.
So if they were a perfect square with one another, will we taking the square root?
We could factor them out of the square root, yes. So example of that, if I wrote it off to the side, perhaps maybe would be if I saw 15 times, let's say 10. Well, I can break that down pretty quickly. That's the same as 3 times 5 times 5 times 2. You okay with that? Can you see that 5 times 5, that's a perfect square? So this would be factored out of the square root. We could simplify that. It becomes 5 on the outside. The 3 and the 2, there's nothing else we can do with them, so they would stay on the inside. And this would be the simplified form, 5 times the square root of 6. Okay, the 5s came out, became 5 on the outside. Okay, number 100, please. That's how we're keeping it. So normally, I would get on your case to read very carefully the prompt, to make sure you're answering the question correctly. This will be the only time you ever hear me say this. Don't worry about this prompt, because this prompt is extraneous. Dare I say, it's worthless. It doesn't add anything to the problem. All you need to do is solve for x. That's it. So I wish this is like telling this kind of boring story. That's all it's doing. Like, all the information's already in the picture. Like, your story has, like, they shouldn't have put all this information in here. They should have let us put it in there, basically. So your job is to solve for x. The big thing you have to understand, folks, is that those 3 triangles, do you see the 3 triangles there? There's a small one, a medium one, and then the large one, made up of the 2 smaller ones. Can you see the 3 triangles? Those 3 triangles are similar by angle similarity. Okay? So if those three triangles are similar, that means all three of them are proportional to each other. It means we can set up a ratio and compare their corresponding sides. So on the small triangle, we're trying to solve for x. That's the short leg. The piece that we are given is the long leg. So we have a short and a long leg. That's a ratio we can make. Look on the medium triangle. Do we have the short leg? Do we have the long leg? Yes, so we can compare those ratios and make a proportion out of them. We can say that x is to 20 on the small triangle the same way that 20 is to 40. Short over long equals short over long. It has to be in the same order. You can't flip them around. That wouldn't make any sense. Compare corresponding parts in the same way. Okay, can you see that the 20 shows up as a geometric mean between these two numbers, the same way we did number 99? Okay, so that's the connection there between the geometry and the algebra. So if you want to cross multiply, you can do that, but you can save yourself the time. Can you see that this is a ratio of 1 to 2? Which means if this is 20, how much should x be? Yep. Totally fine with that. But if you do want to do all the work, that's fine too. Cross multiply, you get this. All right, are we ready to move forward? Am I going too slow? I can pick up the pace. Okay, here they want us to find the measures of the sides of this triangle, and then they want us to classify the triangle by sides as an obtuse, scalene, equilateral, or isosceles. That's a side classification. I'd say we could go ahead and draw a picture here, and we could work from there. But really, we're just trying to find the measure of these sides. We want to know how long AB is, how long BC is, and how long AC is. I think that you could do this in your head. I'm going to show you how. To find the length from A to B, it's basically like doing a Pythagorean theorem. We need to know how far to go in the x, how far to go in the y, square each of those numbers and add them up, right? A squared plus B squared. And then the length, the distance, will be C squared, right? We take the square root. So all we're going to do is find out how far to move in the x, square it. How far we moved in the y, square it, add them up, and then put it underneath the square root. And that is the answer we're going to come up with for each of these. So let's see how far it is. How far is it from 1 to negative 4? It's negative 5. Okay. Square it is 25. So far so good. And from 4 to 0, it's just 4. So 4 squared is 16. So 25 plus 16, what is that?
31.
Close. 25 plus 16? 41. Very good. You forgot to carry the 1. So there's your answer. X squared plus y squared equals the distance squared. Not too bad? We just cut our workload down by a quarter. We did 3 less steps than we had to. We just did 1 step, we had our answer. So understand, you guys are not as bad as math as you think you are. BC. From negative 4 to 3, how far is that in the x direction? 7, so we're going to square that, that's 49, and then 0 to 6, negative 6 is just negative 6. Negative 6 squared is 36, so 49 and 36. What do you get? Add them up. $85. Anybody confirm? 85? Okay, give some head nods. Okay. 85. Hey, not too bad. That's our number. These are our numbers. We can write them out as decimals later if we want to. That's not a big deal. Lastly, AC. From 1 to 3, how far is that? 2 units. That's 4 when we square it. And then from 4 to negative 6 is 10 units. So 10 squared is plus 4? 104. All right. What do you notice about these 3 lengths? None of them are equal. Therefore, what type of triangle is it? Scalene. Obtuse is referring to angle classification. Don't worry, I did the same thing. You even heard me say it. No, That's on the recording. Too late now. Okay. Okay, guys, are we doing okay? Do you need another quick break, or are you good? Okay. Page turn. Okay, this is the page I do the most number of problems with you on. And then there's only one more problem to do on page 8, so the rest are yours. So I'm going to do 11, 112, 114, and 115. So this is all from chapter 7. This is all special segments in right triangles. So altitudes, angle bisectors, medians, and perpendicular bisectors. Those are the special segments. Okay, so we're dealing with angle bisector first. Angle bisector cuts an angle into two equal sized pieces. So these two angles right here will mark as congruent. They're little half angles. Okay, you should do the same. It says here that XW is an angle bisector. Okay, we got that. And then the measure of angle YXZ, that's basically angle X, the entire thing. Oh, we can't see? Okay. So this entire thing, this entire angle, is 15x plus 1. Okay. And WXY, this half angle is 8x minus 1. Folks, how are these related to each other quantitatively? Are they the same? Are they different? No relation at all? What do you guys think? What do you guys think? You're waiting for somebody else to do the work for you. Don't do that, flow host. Work harder. Think for yourself. How are those two angles related to each other? That big angle and this angle right here. I'm hearing one is half the size of the other. You guys agree, disagree? Disagree? Okay. What do you think? She's like, I don't know what it is, but it's not that. Okay.
Is it like if you multiply 8 by 2 over 16, it's 15?
Oh, so in your mind, because it's not becoming 16x, it can't possibly be the same thing? Or be half of? Okay. So Rita's got an argument saying, well, if it was half, then your 8x should become 15x, but it doesn't. And in truth, that's not the case. And the reason being is because it's not just 15 and just 8. If that were the case, yes, you would be right. It's 15x plus something and 8x minus something. So you have to double the entire thing here. If you double the entire thing, what do you get? 16x minus 2. 16x minus 2, that might be equal to 15x plus 1. Right? They don't have to look exactly the same. If they were, you could never solve for what x is. The fact that they don't look exactly the same on both sides means you can compare them, set them equal to each other, and then find out what x is equal to. So yes, when you double this angle on the left, it will equal 15x plus 1. But that's a fair argument. Her way of thinking is not uncommon, right? We've all thought that, like, shouldn't it look exactly the same when I double it? No. If it does, then you wouldn't be able to solve the equation. Right? If I say x equals x, so 2x equals 2x, well, you can't solve for what x is then, right? So now I'm going to solve for what x is by subtracting 15x to the other side. It gives me 1x. I'm going to add the 2 to the other side, and I get 3. So now, test the theory and see if this helps us to actually show the thing that they gave us. I put 3 in. 8 times 3 is 24. Minus 3 is 23. So this is 23 degrees if I make this 3. 15 times 3 is 45. Plus 1 is 46. 23, 46. Are those half of each other? One half of the other? So it does work. It does have that system in place. And folks, we know that that relationship was the case because this was an angle bisector. So it's something you learned in the first 3 weeks of school, and we've been using it ever since. When you bisect an angle, you get 2 equal angles. So therefore, doubling this definitely gives you this bigger angle. All right, so we now know that that's 3. They also tell us that this bottom angle here is 22x. Well, if x is 3, then how big is this angle? Okay, 66 degrees. Excellent. So that means our answer should be C. But they have a follow-up question as well, and it's an important one for you. It asks, is XW also an altitude? It's an angle bisector right now. Can it also be an altitude? Well, what do we know about altitudes? Anything? What do we know? They do go up and down, that's true. They go from a vertex of a triangle to the opposite side, and when they hit the opposite side, something happens. What makes an altitude an altitude? Think of it as a height. It has to make a right angle with the side that it hits. Right? Altitudes are perpendicular to their bases, always. So if that angle measures 90 degrees down here, then it's an altitude. If it doesn't measure 90 degrees, it ain't an altitude. So can we find out if it's 90 degrees? Have a look at the picture. See if there's any way of finding that out. How can we determine if that's a 90-degree angle right there?
By adding the angles and then subtracting 180.
Yeah, okay, so Cassandra's got an idea. So we know that this angle here is 66. So I'm guessing we could look at triangle XWZ. Can you see that triangle right there?
So we're going to do I-66 plus 46 and subtract it by 180.
Well, if we do that, that'll give us this angle over here. Look at this half angle. So this half angle right here, how much is it? 23 degrees, okay. So these two angles, what do they add up to? 89 degrees. If that's 89, how much is this angle down here? 90? 91 degrees. So, is it an altitude? No, it's not making a 90-degree angle, so it's not an altitude. So that's why the answer is no. Okay. I'm concerned. Some of you are definitely thinking about this. Some of you are just passively waiting for this to be over. Let me put some fear into you. Your final, the benchmark, is worth 20% of your grade overall. It's way too heavily weighted in my opinion. That means, let's say you're getting an 80 in the class right now. Let's say your grade in the class is 80%. That means that you have earned 64% of the possible credit for the class. Okay? That means if you got a perfect score on the final, you would get 84% in the class. If you bombed the final and got nothing, got 0, your final grade would be a 64. Does that make sense? Can you see that you really don't have the option to risk doing poorly on the final? That being said, you have to do whatever you need to do to stay intrinsically motivated. That means if you need to stand up, to move around, to get the blood flowing, be engaged. I've seen way too many people that are just kind of detached, like, wait for somebody else to figure this out for me. I'll write it down and not think about stuff because I'm kind of tired right now. You're going to be tired for a long time, okay? You're going to be tired this week. I'm tired this week because we just got back from break. You have to power through. It's not enough just to show up, okay? I need you to step up. And more importantly, you need you to step up, okay? It's important to me that you do well, not because I need you to do well, but because I want you to do well. I hope for your sake that you feel similarly, that you want to do well. So please make those adjustments. Make sure you're actually trying to participate. Give feedback. Answer questions. Don't let the same 4 people do all of the answering for you. It's a waste of your time. And frankly, it's disrespectful to the class as a whole that you're withholding the opportunity for yourself to learn. So take that opportunity, guys. Okay, jump down, if you would, to number 112. says P is an in-center. When you hear the word in-center, what kind of things come to mind? It's in the center, killer. That's in the word. Very good. Anything else? Yes, a circle. It's the center of a circle that is inscribed inside the triangle. And it touches the triangle on all three sides. Those sides are right here. K, J, and L. That's where those circle would touch on all three sides. So if that's the case, what would that mean that PK, PJ, and PL are on that circle? What would you call those things on the circle? What would PK, PL, and PJ be in our circle? Radius. It'd be the radius, right? Those would all be the radii of our circle. So they're all congruent then. That's the big thing. That's the big thing you have to remember with incenters, is that those segments now are all the same length. Alexis, stand up. I'm going to fall asleep. No, literally, stand up. It'll help you. Grab a whiteboard, use it as his back, and you work from the standing position. He's like, Mr. Duncan's calling me out. Nope, just trying to help you learn. Okay, so we now know that the next piece of information they give us is that PY is 68 and JY is 60. Okay. They want us to figure out the length of LP, but here's the thing. LP is the same length as PJ. So if you figure out what PJ is, it's the same number, right? Well, look at PJ. With those other two legs, what do we have? What do you see? Yeah, it's a right triangle. You know two of the sides. What do you think we should use? Definitely, it's a Pythagorean theorem problem. So a squared b squared equals c squared. Off you go. So escribelo. Con furiosamente. Okay, so I'm guessing you're pretty close to finishing using the Pythagorean theorem. I happened to notice that the numbers here looked like they were factors, right? I saw that 68 is the same as 4 times 17, and 60 is the same as 4 times 15. You're like, well, why does that matter? Well, that means if those are 15 and 17, I know that those are two numbers from a Pythagorean triple. 8, 15, 17 is a Pythagorean triple. The cool thing about Pythagorean triples, in case you've forgotten, that they're numbers that when you square them, they equal a right triangle. So 8 squared plus 15 squared equals 17 squared. Any scaling up of a Pythagorean triple is also a Pythagorean triple. So if this is 4 times 17, that's 4 times 15, and this is going to be 4 times 8, which is 32. So it just saved me a little bit of time. But it's ultimately using the Pythagorean theorem and similar triangles in kind of a clever way. So there is our answer. Okay. All right. Shall we move forward? Yes? All right. On we go. Alexis, you feeling better? You want to stay? You can sit down if you wish, but it's up to you. It's like, I'm kind of okay. Okay, centroid. Folks, when you hear centroid, what's the big important fact about centroids that are useful to us? They are a measure of center. This is true. It's the word centroid. That's nice. It's like in center. What else? It deals with a fraction, a very important fraction. The 1/3 or 2/3 fraction. So centroids are always found 2/3 of the distance of their median that they're on. Centroids are on medians, and the centroid is located 2/3 of the distance down, or 1/3 of the distance up, I guess you could say as well. So that'll help us figure out a couple things. It says here that WN is 32 units, and that's 2/3 of the entire thing, which means that NT must be 1/3 of the entire thing. That makes sense? Well, if that's 2/3 and this is 1/3, that's a 2-to-1 ratio, 2/3 compared to 1/3. So that's 32. This should be half of that. What's half of 32? 16. So that's 16. So the whole thing, if we add it up, should be 48. Okay. Some people are not sure where I get the 16 from. You need to talk about that? Okay? Okay. Okay. So we now know that length is 48. We also know that WC, this length right here, is 50. And they want us to figure out what this is, TC. All right, what do you think we're going to use? Yep, Pythagorean theorem again. So if you want to use Pythagorean theorem, feel free to. I noticed this is another Pythagorean triple, though. So it's the Pythagorean triple 7, 24, 25. It's not a very common one in terms of being used in high school, but it shows up sometimes. It shows up here. Did you need to know that that was a Pythagorean triple? No, you could totally use Pythagorean theorem here and you're fine. Right?
Can you show that the other one?
Pythagorean theorem? Sure. A squared, B squared, C squared. And we have TC, we don't know, square, plus 48 squared equals 50 squared. TC squared plus now 48 squared. Ooh, that's a big one. It's 48 squared. Who's got that? 2,300? 304. 50 squared, that's 2,500. Subtract. Ooh, not enough room. And we get TC squared is equal to 130. That can't be right. 136? I guess so. Why does that feel wrong? 196. How did I get 60? Oh, it's 0. It's not a 6, Mr. Duncan. Really? Really? My handwriting finally caught up to me. Okay, so take the square root of both sides. You get TC is equal to the square root of 196, which is 14. Can you see why I like the Pythagorean triples now? Took me like 2 steps with the Pythagorean triples. I'm like, oh, okay. These are triples.
Yeah, I don't like it.
Don't like them?
Confusing.
Oh, think of it as, yeah, think of it like similar triangles. So imagine, if you would, that the side lengths of the triangle they give me are 4 and 5. Okay, the hypotenuse is 5, one of the legs is 4. Then I know the other leg has to be 3, because a 3, 4, 5 triangle is a Pythagorean triple. If I get 6 and 8 instead, I go, wait a minute, 6 and 8, that's the same as 4 and 5, just 3 and 5 just doubled. 3 and 4 just doubled, excuse me. So I go, oh, 6 and 8, that means the next number should be 5 doubled. 3, 4, 5 doubled. It should be 10. So 6, 8, 10. Still nothing? Sounds like I need to talk about this more. Okay. I have 2 more problems to do. I guess I'm going to be coming back to Pythagorean triples for some folk. The vertices here are given, and we are trying to graph it, find the distance formula to find how length with the links, find the median, and then graph the median. Okay, here we go. Draw a picture quick, because it says to graph it first. So there's L. Oh goodness, 1, 2, 3, 4. So there is M, And n is at 1, 2, 3, 4, positive 1. Okay, triangle's graphed. Terribly, but graphed. It says use the distance formula to find the length of each side to the nearest tenth. That's easy enough. We've done that before. We did it in our heads. Don't think you needed me to do that, but we'll do it quick. All right, LM. It's 3 units. I'll wait for you to write it down. I don't want you to get behind. LM, that's 3 units to get from 1 to 4, so that's 3 squared. And then 3 to 0, that's 3 again, squared. So 3 squared plus 3 squared, that's 9 plus 9. That's the square root of 18, which is the same as 3 squared of 2 if you want to simplify it. And then you can use your calculator to get your decimal. I don't care. MN, 4 to negative 4, that's 8 units. And then from 0 to 1 is 1 unit. So 8 squared is 64. 1 squared is 1. 64 plus 1, 65. And then you can simplify that to the nearest tenth. It's 1 decimal place. And lastly, L to N. 1 to negative 4, that's 5 units. And then from 3 to 1, that's 2 units, negative 2 units. So 5 squared is 25. 2 squared is 4. So square root of 29. There are my 3 links. So that's the distance formula taken care of. All right, last 2 actually are really easy. We need to plot the median, rather the location of where the median goes. So the median goes to the midpoint of a side. So we need to know where the midpoint is on MN. It should be easy. We add up the coordinates and we divide by 2. So 4 plus negative 4 is 0, divided by 2 is 0. So it's at 0, it's on the y-axis. 0 plus 1 is 1, divided by 2 is a half. So it's going to be 0, comma, a half. So that is going to be point O is going to be at 0, comma, 1/2. And it says, lastly, graph the median. Well, the median is just the line that connects the vertex to that midpoint. So there it is. There's D. Done. Okay. Questions there, folks? We're okay? All right. Final stretch. You ready? Turn the page when you're ready. All right. I'm only doing one problem on this page because the rest I think you're pretty well ready, can do without me. In fact, I think you can do this problem without me too, but just to be certain. It says find the measure of angle y. Okay, we're finding an angle. If the measure of angle y is 6 more than 3 times its complement. So we're dealing with angles. When you hear the word complement, what should come to mind when it comes to angles? Say again? 90? Anybody else? Is it 90? Okay, so complementary angles add up to 90. So 2 angles that add up to equal 90. Is that correct? 2 angles that add up to equal 90? All right. Well, I'll call this one angle y. Measure of angle y. The other one, just I need a name for it. I'll call it the measure of angle z. Just whenever you use z. Now, we don't know what the measure of angle z is, so let's give it a variable. We'll give it the variable x, because that's just weird. Let's do it anyways. So that value we'll call x. Well, we know that y is how much? 6 more than 3 times that guy, right? That's the complement of this guy. So 3 times x. So there's our equation. All right, is that okay? Is that sitting well with you? So now you just add them, solve. So 4x plus 6 equals 90. I've already added the x to the 3x. That's how I got here. And then 4x equals 84. So x equals 21. Is that our answer? X equals 21. It's one of the answer choices. Yes, no? Oh, because we actually want to find angle y, don't we? So what should we do with this number? You could plug it in. What else could you do? That'll get you the right answer. What else could you do? They're complementary, so therefore they add up to. So what can we do? Subtract it. And I mean, of course, you could have plugged it in. That's totally fine. But I think this is faster. So that's going to give me 69 degrees. So there's your answer. First time I did that problem, I totally circled number 21. And someone's like, Mr. Duncan, I think that's the wrong answer. I'm like, but the math is right. They're like, you didn't do enough math. Well played, student. Well played. Okay, so that is all